Hello and welcome to yet another video tutorial, whatever you want to call it, episode of Codamy. Today what we are doing is we are creating something in processing. Processing is a Java based environment which it is very easy to create sketches. You can make lines, draw rectangles, ellipses and other stuff very easily. So the language will be mostly like Java. It is basically Java, but some things will be different. So what we are building is this. This is a maze generator. It generates a maze using an algorithm, and then it tries to find its way from start to finish, and the finish is selected at a random point in the last row. Start is always at this beginning, and it then draws a path from start to finish, which is the optimal path, or you can say the shortest path which can be there. So let's begin. To start with, I have two files. One is the maze generator, the other is block. And in the processing, what we have is two basic functions. One is the setup function, the other is the draw function. And in the setup, the setup function only runs once when we start our sketch. The draw function then runs over and over again like a loop until we stop it with the no loop command, or we can just simply stop the animation. So if we see here, what this is basically a block. So what we will be doing is making a grid of blocks and then render them on the screen to start with. Sorry, I forgot to mention that we'll be using two Wikipedia sources. One will be the A-star search algorithm, which I'll be doing in the next video, not this video. This will be the maze generation algorithm that we'll be doing in this video, and this will have the recursive implementation. We have other implementations also, but I think this one is the simplest, and this one we'll be following today. Okay, so the first thing is make a maze. So this will be our basic block. You can say what it needs to have is every block needs to know what is its x position, y position, to that these points will use to draw the rectangle on the square on the screen, and it also needs to know what row and what column it is in, and this is the show function that we'll be calling in order to draw the shape on the screen. So it is giving me some error. Maybe I need this. Oh, sorry, I need the semicolon here. So let me elaborate a little further. So here, if we have this is the first function, first point, which is xy, and the size is this length or the height, which will be same, then this point will be x plus size, sorry for my writing, y, and then we can, the same way we can find out this will be x plus size y, and this will be x plus size, y plus size, and then this you can see here, and then this, so you get the point. So this way we can make 4 lines, and then we can like that, in that way we can create our square. Let's remove that, and this size function, this size variable is not defined here. I will be initializing it in my main file. So let's do some stuff here and then get back to you. Here I have initialized one single block and given it its row and column. For now I'm just giving it in the single 0 0, so it should create, and then I'm calling this show function. So what it should do is it should come here and initialize its x and y, and after initializing its x and y, I should be able to make these 4 lines to form a square on the screen. So let's see. So we have a single square on the screen, you can see that. So what it is doing is I'm declaring a block, which is this, making an object of this block, and then I am initializing this block with the 0 and 0 for its row and column. And here what it is doing is it's saving this information as an x and y and row and column, and then I'm making 4 lines on the screen to show this here. So let's move forward to making a whole bunch of squares from here to here, like a grid. So what I'm doing here is I have a nested loop, and I'm creating a 2D array for blocks. There will be the blocks will be an array of blocks, and each block will have its own I and j, and then I'm calling the on every block I'm calling the show function here. So this is giving me a null pointer exception here. Let me see why. Blocks 0 0 ij, and I should initialize this to, oh sorry, I forgot to initialize that, or sorry, because I have only declared it, and by default I think it is 0 and 0. So what I need to do is I need to initialize this blocks array with new block and how many rows and columns, and I have to do it here because here I don't know how many columns and rows we have until we define the size of our sketch. Let's now run it, and we should see a whole bunch of squares on the screen. Okay, so we can do this only once, I guess, in the here, and we do not need it again. And actually we don't need it here also, because we'll be drawing over and over again on top of this, but for now let's keep it here. So the next thing that we want to do is we want to start from here, and then we want to move from here to a random neighbor of this. So a neighbor would be anywhere left, right, or top or bottom. So for example, for this specific one, this and this will be the neighbor, and it can move either here or here randomly. We'll choose that randomly. So for now let's code that. So if you see here in this algorithm, what we have is we want to give the current cell as a parameter. For example, we want to set the starting point as a current cell and then mark this as visited, but we don't have any field in our block that is taking care of that. So let's go to our block and add that. This will be a boolean, and initially every block will have it by false, and whenever we visit a block, we'll set that as true. So let's move ahead. The frame rate is basically the speed at which we define the how much time does it take after how much time this draw function is called again and again. So in order to just see what we are doing, I have set it to a lower rate, and then we can increase it later to see the animation properly. So here I have created an if statement, and with the variable is maze finished, and I'll initialize it here somewhere, and initially it will be false, so that I know when my maze is finished I can stop this loop or do other stuff, which we'll be doing in the next video. So I have this variable to tell me that, just to have that in check. So let's move forward. So what I have done so far is just move the draw logic from the setup function to here, and so that I have them over and over again. If I move them back here and run, we'll see a blank screen because this background is being rendered over on top of this these squares, so it has to be here. So let's move forward and start by like marking this as the current maze block. So now what we can see that which is our current maze block. What I'm doing is basically making a rectangle on my current maze block from its x and y, and with the height of size and the width of size. Now if I change this to like 5 and 0 and run it, so it should move. Sorry, it is moving in another direction because maybe something is wrong with this is my column and this is my row. So we'll just remember that. So we can see, but we will start from 0 0. So that is our starting point in our maze. So what we want to do now is we want to move from here to one of these neighbors, and we currently we don't have any logic for neighbors here. So let's move to our block and add that logic here. So here I added some things for before implementing the logic of moving from one box to another, which is the walls. So this array represents there are four booleans inside it. The first one represents the top wall, the second one the right wall, then the bottom, then the left. The order may be a little bit off, but we'll see later. So here what we are doing is if I go here and let's make this false, and also let's make this false, so we'll see that there are no more left and right lines. So in this way, what we want to do later on when we move from one block to another, what we want to do is remove the wall between them. So we need to have some like boolean, have some variable that can tell us whether or not there is a wall and whether or not it should have the wall should be rendered there or not. So what I can do is whenever I move from here to here, I can just change this to false and this wall will not be rendered on the screen. So let's now implement the movement logic. So this will be our function that adds the neighbor to gives the knowledge to every block which ones are its neighbors. So what I'm doing here is I'm checking. So if we see here, okay, so the neighbors is not defined. Let's quickly add the neighbors array here. This will be, so I can make this an array right away and it will not have any issues right now, but I know that later on I will be removing neighbors from this array, so I have to make it an array list, because arrays we cannot change the size of arrays in Java. So we'll have to make it array of block, and this will be called neighbors, and it will be new array list of block. So that's why I used add, not push and pop, because there is no push and pop here. So if we run this, what we will see is the same thing, but now each block has the information of which ones are its neighbors. So what these conditions are doing is if I am in the top row, I do not have to add any square as a neighbor that is on top of it, and same as if I am in the leftmost column, I do not have to add the neighbors on the left, and if I am the same thing here and here. So these conditions are checking that and avoiding any null pointer exceptions for that matter. So let's now move ahead, and as of now none of the blocks have this information. So what we need to do is we need to call this here. I think we can call it in the here. Add neighbors, and if I run this now, add neighbors doesn't exist, so maybe I misspelled it. Yeah, let's now run it. So now what is happening is whenever when we run it, the setup function runs once, it is initialized, then it is all the neighbors are added, and then we move for our animation and we show all the blocks on the screen. So now we can choose a random neighbor and then move from my current block to the next block. Let's add that functionality. So we have done 2-3 things here, and we need to write a lot of code to actually make this work. So what we have is we are checking whether or not this current maze block has unvisited neighbors. So if you remember, we had a Boolean variable that kept track whether or not this is visited. So when we first made the current block, initialize that, set that to true. So now whenever we visit another block, we have to set that true, but before visiting that, we have to check whether or not that has been visited before. So first we check if it has unvisited neighbors, then we go ahead and pick a random neighbor. So we have to write two functions that which will be has with unvisited neighbors, and another one will be the pick random neighbor here. So let's go and do that. So this will be our has unvisited neighbors. What it is going to do is it is going to check the neighbors array. If any of the neighbor has the visited by maze flag as true, the condition will be satisfied and it will return true. Otherwise it will result false, as none of the it has no unvisited neighbors. And so the next thing is to implement pick random neighbor. So this will be our pick random neighbor function. What it does is maybe a handful. Let me explain. It goes it gets a random neighbor function. It gets a random block from neighbors. How it there's a function in processing which is random. It takes two parameters. First one, and whenever this function is run, it gives us a random value from this to whatever the next value is. In this case, I have the size for initially it will be either 4, 3 or 2 based on where we are. So it will give me either 0 from 0 to 4, and then I float it just to convert that into an integer. Then I get that neighbor from the neighbors array. And it is possible that it has already been visited by maze. So until I find a neighbor that is not visited before, I loop through, and it will run only maybe 2 or 3 or 4 times once. And if it has been visited before, I remove that and pick a new one, and then I set the visited by maze flag as true, and then I remove that neighbor from the neighbors array and then return that neighbor. So now we have the random neighbor in our next current block, and there's this stack. So what is this stack basically? See it visually. Let me see if we can see it visually. Here we can see that it is moving, and we can see from where it is moving, and then it stops. But it should not do that. Let's see why it is stopping. So, and it is picking a totally random neighbor. Let's run it again. Maybe there is something wrong with my picking neighbors, but you'll see. we'll see why it is stopping. But the whole point of stack is whenever it gets stuck, for example, if it moves here and comes from here to here, then it will have no other neighbors to go from. Then it will have to go back here then to find a new neighbor that has not been visited. So we have to know where we are going, and then we'll push this block to neighbor, this block stack, this block to stack, this block to stack, this block to stack, and then we will come back one by one when we see what is inside the stack, this. So let me finish the logic, implementing this logic, then come back and we'll see why it is getting stuck here. So it is kind of working, but there seems to be some problem. It goes to the bottom and then starts going back one by one. Okay, so maybe there's something wrong with my add neighbors. Let me find out what the problem is, and then okay, so I guess this is the problem. So when our this dot column is greater than 0, that means we are not in the leftmost line. So this should be -1. I think that's the problem, because that, yeah, now it's working. So what it did is it didn't add this neighbor until it reached this line, this column here. So I think now it's working properly. It's finding the random neighbor and then going back to find another neighbor until it finds it, and then it will go back to its initial position and stop. Okay, so what we can do is, to stop the loop, we can come back here and we can print maze done and say no loop just for now. Actually, I don't know if it will come inside here, but we'll see. Yeah, it will come here. Okay, so what we want to do now is we want to remove the cell, remove this wall from, let me decrease the speed a little, like something to 2. So what we want to do is, when it moves from block to block, we want to remove the line between them. So actually this is not a single line, these are 2 lines, one line of this block and one line of this block. So we want to remove the right from this one and the left from this one. So let's implement that logic and come back again. So I think this should be it for the remove walls function. What it does is basically finds the if you want to keep track from where we are moving and to where we are moving, what we can do is we can check the rows of both the blocks. But we want what it does is finds the x distance. If the x distance is -1, so maybe it is moving left to one block, and we want to remove the left of the current and the right of the next block, right line of the next block. What we are doing is setting the boolean of this array true as false. So in the next render, this will not print either one of these lines. So and the same goes for the y. Let's run it. Okay, it seems to be doing nothing. Let's see why. Oh, I think I forgot to actually call this. So we have to call this function right after we find a new one. can call it here, remove walls, and we'll say current maze block and next. So because we'll move from this block to this, so we have to call this, actually call this function here. Let's say run this, let's see. Okay, so now it's removing the walls as it goes. And if I increase the speed a little, some 20, if I run this, all right, I think it is doing a good job. And there we have it. So this is our maze generator, and it says the maze done and stops the loop here. So this is our maze. That's how we did it. In the next video, what we will be doing is we'll be applying the A* search algorithm. What that will do is basically start from this point, and we'll pick a random point at the bottom. We can pick any point, but just to be like make it more interesting, we'll pick any point at random from the last row, and then try to find our way from this point to that point with the minimal distance. So thank you for watching. Goodbye.